Hi guys, my name is Katia Chavez and I work at the Natural and Social Science Lab at the Miami-Dade College, Kendall campus. Today we're going to continue reviewing our lecture on hydrocarbons. So we are going to learn this time how to draw structural formulas starting with condensed formulas. But before that, we have to remember our golden rule. Remember? Last time we said that a carbon atom must always have 4 bonds. So that's something that we have to remember from our last lecture. So let's start with this problem. They give us this condensed formula and we have to find out how to draw the structural formula. And if you remember, the structural formula is a formula in which we write down all the bonds between carbon and hydrogen atoms. So something that you need to know is that whatever is to the right of each carbon is going to be the atom that is bonded to it. So in this case, for this carbon here, what's to the right of that carbon is this one, these 3 hydrogens, right? So these 3 hydrogens are going to be bonded to that carbon. Let's take a look at the next carbon. It is bonded to these 2 hydrogens. For this carbon here, it is bonded not to 2 hydrogens, but 2 molecules of CH3. That's why this subscript indicates 2 CH3 molecules. So all this is being bonded to that carbon. Here, interestingly, I have 2 different atoms bonded to this carbon. In this case, hydrogen and iodine. And here, finally, for this carbon here, I have 3 hydrogens. So I know that in my main carbon chain, I must have 1, 2, 3, 4, and 5 carbon atoms, right? Let's do that. So this is my main chain. 1, 2, 3, 4, 5. And because it's a carbon chain, I must draw a bond between each carbon atoms. Next, I need to follow my golden rule that tells me that each carbon atom has 4 bonds. So let's take a look at this carbon. This carbon already has 1, so I need another 3 to complete the 4. Let's take a look at that carbon. That carbon has 2 bonds, so I need to complete 2. Same thing here. It already has 2 bonds, so I need another 2. Same here. It already has 2 bonds, so I need 2. And lastly, I have 1 bond here, so I need 3. Okay? Next, this carbon here is going to be representing this carbon here, but it is bonded to 3 hydrogens, so I need to put them wherever their bonds are available. And since this carbon is already occupied by another carbon, I need to put the hydrogens here. So 1, 2, 3. And I have CH3 and CH3, so I'm okay. Now let's take a look at this carbon in the middle. It is representing this carbon here that has 2 hydrogens, right? So I need to put the 2 hydrogens here and here, because those 2 other sides are completely full. And I have CH2. Next one, this carbon is going to represent this carbon here. And I need to put a CH3 on every space available. That means here and here. Next, for this carbon here, it is bonded to a hydrogen and an iodine atom, right? So I need to put them here and here, because these 2 sides are already full. Hydrogen and iodine. And lastly, I need to put these 3 hydrogens for this carbon atom, that is this one. 1, 2, 3. And supposedly I should be done, right? But the problem is that I'm not showing all the carbon and hydrogen bonds. Actually, let's take a look at this. and this. I need to show in detail the bonds between the carbon and each of the 3 hydrogens that I have here. So let's take a look at that. So as I was explaining before, I needed to draw the bonds between the carbon and hydrogen atoms for each CH3. And I've put them here. Okay, it's CH3 because this carbon is bonding to 1, 2, 3 hydrogens and another carbon. And I also put my iodine in another color. So this is the actual structural formula, because it is showing all the bonds between carbon and hydrogen atoms. So now you should be ready to draw any type of formula, whether structural or condensed, and know how to do the conversions from one to each other. Just remember that the most important rule is that your carbon atom must always have 4 bonds. Okay, so stay tuned.